Hello everybody, welcome into another lesson. Today we are going to talk about Pythagorean Theorem. So what is Pythagorean Theorem exactly? Well, I spelled it up on the top of the board for you. But Pythagorean Theorem deals exclusively with right triangles. This only works on a right triangle. So of course in a right triangle, the first two sides that form the right angle, they're called the legs. You have one leg and another leg. The slanted side directly across from the right angle is called the hypotenuse. That's what the slanted side is called. The idea of Pythagorean theorem is that you can take the length of one leg, we'll call that A, length A, raise that to the second power, and then add the length of another leg to the second power, and it should equal the hypotenuse length C to the second power. So that's where we get A squared plus B squared equals C squared. So let's do some examples here of some lengths. Let's see here. Do a very common one that we know. Let's say A equals 3, B equals 4, right? We're going to have A being 3, B being 4, but we don't know C. Well, what we can do is take the A squared, which in this case is 3 squared, plus that 4 squared, which is B squared, and we can set that equal to the length of the hypotenuse, C squared. We don't know what C is, but that's okay. We will get there. So now, of course, order of operations dictates we do the exponents first. So 3 squared is 9. Plus, you have 4 squared, which is what? 16. That's all equal to C squared. Now, if I were you, I, of course, would do the addition on the left-hand side. 9 plus 16, that's 25. So 25 is equal to C squared, right? Now, we want to get the length of C. We have C squared. We want to get the length of C. I can rewrite this first as C squared equals 25. In order to get the length of C, we need to take the square root of C squared. But what you do to one side, you have to do to the other. So we're taking the square root of C squared, which means we also got to take the square root of 25. So the left side, the square root of C squared, well, the square root of something squared is itself. So you'll get C is equal to, what is the square root of 25? Well, we covered that yesterday. Square root of 25 is 5. It's a perfect square, so it equals 5. So we have found the length of the hypotenuse, C, to be 5. And these could be any units. We're just dealing with numbers today. But the length would be 5 units there. Alright? So that's how you find a missing side length. Let's do another one here. Let's do 6 and 8. We'll let A equal 6. So A is 6, so that's 6 squared. Plus, we'll let B equal 8. So that would be plus 8 squared is equal to C squared. We don't know C. That's the length of the hypotenuse. That's equal to C squared. Again, order of operations dictates we do the exponents first. So 6 squared, that's 36, plus, what is 8 squared? That's 64, which is still equal to C squared. We don't know what C squared is. So, of course, on the left side, we're going to do the addition. 36 plus 64 turns out to be 100. You'll have 100 is equal to C squared, which we can rewrite as C squared equals 100. To make our lives a little bit easier. Okay? Now we know what c squared is. That's 100, but we don't know c. Well, in order to get c, we got to take the square root of c squared. But what you do to one side, you got to do to the other. We also got to take the square root of 100. So the square root of c squared, that's just c. Now the square root of 100, that's 10. So we would get the missing length for the hypotenuse being 10. So c equals 10. That's the missing length for the hypotenuse. Okay. Let's do one more example of finding the hypotenuse. Let's say we have 10 and 12. We have 10 and 12, right? So a squared, a squared, well, yeah. A squared equals 10 squared, because a is 10, plus the b is equal to 12, so that'd be 12 squared. A squared plus b squared equals c squared, the unknown length for the hypotenuse. Well, what's 10 squared? That's 100, plus what is 12 squared? That's going to be 144. That is equal to c squared. Now on the left side, of course, you're going to do your addition. 100 plus 144, well, that's 244, which is equal to c squared, which can be rewritten as c squared equals 244. Now, of course, we know what c squared is. We want to know what just c is. Again, you would have to take the square root of c squared. But what you do to one side, you got to do to the other. So you would also take the square root of 244. All right. Now the square root of c squared is just going to be c. Now, what is the square root of 244? I could tell you it's not a perfect square. We're going to end up getting a decimal approximation. We're going to round this to 2 decimal places. So, square root of 244, that's going to be approximately equal to 15.62. So let me make the approximately equal sign. 15.62. So the hypotenuse is approximately 15.62 units, since the square root of 244 is not a perfect square. And so that's really all there is to finding the missing length of the hypotenuse. Now I'm going to twist this a little bit. Let's say this time you know the length of the hypotenuse to be 13, right? The length of the hypotenuse is 13. The length of the first leg, A, is equal to 5. We don't know the length of B. That's okay. We can still use Pythagorean Theorem to solve for B. How, you ask? Well, let's take 5 squared, which is A. A is 5 squared, plus b squared, which we don't know. That's equal to c squared, which would be 13 squared. Of course, in order to proceed with this, the first thing we have to do is the exponents. That's the order of operations. So 5 squared is 25, plus b squared, which we don't know, is equal to 13 squared, which I could tell you is 169. That's 13 squared. Now, we have the variable b squared. We want to isolate that by itself. What you're going to have to do is subtract 25 from both sides. So if you do that, you'll get b squared by itself. That's going to equal 169 minus 25, which means b squared, you have 169 minus 25, that's 144. Now, of course, we got b squared. We need to get the length of b. Well, you would just take the square root of b squared, But what you do to one side, you got to do to the other. You got to take the square root of 144. Okay, so square root of b squared is just going to be b. Square root of 144, that happens to be a perfect square, it'd be 12. So b has length 12. The answer to that is b is equal to 12. So you can also use it to solve for, you can use Pythagorean theorem to solve for any missing length besides the hypotenuse. It still works. Alright, let's do one more for good measure. Let's say the hypotenuse equals 20, c equals 20. Let's say b squared equals 15. Let's say b equals 15, but we don't know a, right? So a we don't know. We know b equals 15. The hypotenuse c equals 20. Well, we could still use Pythagorean theorem to solve for that missing length a. Of course, you would have a squared plus b squared, which b is 15. That'd be 15 squared, which would equal c squared, which is 20 squared. Alright, order of operations dictates, of course, we do the exponents first. Well, a squared we don't know, that'll stay as it is, but 15 squared is 225, which is equal to whatever c squared is. 20 squared, that's equal to 400. Alright, now we want to isolate that variable a squared by itself. How are we going to do that? We're going to subtract 225. Of course, we got to do that to both sides, because what you do to one side, you do to the other. So if you subtract 225 from the left side, you'll get a squared by itself. You have to do it from the right side. You'll have 400 minus 225. Okay? So a squared, the result of 400 minus 225 is equal to 175. Now that's great. We know the length of a squared. We don't know the length of a. Well, in order to get just a, we have to take the square root of a squared, which means we also got to take the square root of 175. Well, square root of a squared just turns out to be a, and I can tell you the square root of 175, that is not a perfect square, so that's going to have to go into the calculator. So let's see, square root of 175, rounding in 2 decimal places is about 13.23. So a is approximately equal to 13.23. That's the length you would get for a, is approximately 13.23. So really, again, Pythagorean theorem, the idea is you could take the length of the first leg to the second power plus the length of the second leg to the second power instead of equal to the length of the hypotenuse of the second power. Length of the first leg being a, so that's a squared, plus the length of the second leg squared, b squared, is equal to the length of the hypotenuse, c squared. You can use it to solve for length of the hypotenuse, or you can use it to find for the length of any legs that you need. So, really that's it for Pythagorean theorem. There really isn't much to it. So this was the last lesson of the geometry unit. The next lesson is going to delve into the real number system. We're going to introduce negative numbers and take in the absolute value of numbers. So stay tuned for that. I hope everyone has a good day. Take care.